I'm DaRon.
And I'm Roniel. And today we have a really special treat for you guys. It's another look at some malware or malware, whatever you want to call it. And this is pretty much a part one, part two series. So we're going to go and dissect the malware in the first section, and then we might go even more on the other intricacies of that application itself.
One of the big things that we're doing as part of this demonstration, we're actually going to show you two separate, one today and one in our next episode, two separate advanced persistent threat malware. It's utter rubbish. But the point is to show you what we've been saying for some time, that there's this constant spin trying to claim that this stuff is so advanced. Both of these actually came from China, and both were used as part of two separate massive campaigns, one in 2017 and one in 2021. The first was when they were attacking government systems worldwide, trying to take them out with a struts vulnerability, which is why it will be a JSP. And then the second one was when they were exploiting the Microsoft Exchange vulnerability. But we'll get into the second one in another episode.
And I have to say, just so you guys get very close, it is not advanced, okay? Read my lips, not advanced.
That's right. There's nothing advanced about any of this, and arguably it's not even persistent.
I hope you guys enjoy, so I'm going to kick it off to DaRon to actually go and do the demonstration.
So this first application you may or may not recognize, it's called CKnife. And again, it's heavily used actually by the Chinese.
Does it have a knife in it?
Actually, we'll go point it out, but one of the they have a little bit in here where they're doing adding some characters to a string, and it is effectively the strokes you do to do the word knife in Chinese.
Oh wow.
Yeah.
Interesting.
Yeah. All right, so looking at this, it's actually not very long. We can scroll all the way down. We see it's approximately 113 lines long. What we see up front is they have all their methods. PWD is supposed to be a password. They don't really use it in a meaningful way. We'll get to where they actually use it. And then CS typically would be a character set. You're going to see that this is poorly written. It's incredibly poorly written, and we'll go through it and hit some of that as we do. So the first method we see is this EC method. All this does is it takes in a given string, and then it tries to, it breaks it up into a byte array using the predefined character set ISO 8859-1, which is extended ASCII. And then it creates a new Java strings being Unicode. So what they're really trying to do is translate extended ASCII into Unicode. That's all the EC method does, and then it returns the ensuing string. GC is responsible for connecting to the database. So this is your database connection, and when we look at it, you'll see we've got this CHORA HEI. That's like a mischievous laugh. HEI. It's like a kind of like a kind of deal. And what they do is they take the input, which is going to come as one of the parameters we'll see later on, but they take the input and then they split based on that string. So in between each one of these given parameters, it just big split. Now, what that winds up doing is you're going to see, this is really your database connect string, right? And all that they did was to try to break it up, I guess. Maybe the intent was that it'll slip through a little better if it's interleaved. So instead of being JDBC : Oracle : / IP address, slash all that other stuff, or I guess you could have another colon if you have to include the port, that kind of thing. They try to break up that URL, that connect string. And that's why they have to do this. The first part of it is the database driver. So they would include the actual class for that database driver. And then after that, for example, if they were doing Postgres, they would have Postgres' driver. And then after that, they would have the next index would be the JDBC Oracle or JDBC Postgres or JDBC MySQL, whatever it happens to be. And then after that, we see they expect another one here. And what they're checking is whether or not it's /null and all this other stuff. They're really, I'll tell you, if you actually look at this, anyone who knows anything about writing code knows they didn't make this very robust, right? So what happens if you have less than 5 items in your array? It's going to crash, right?
Yeah. Segmentation fault.
Yeah, well, yes. Array index out of bounds in
and
Java,
I was just about
but
to say,
same thing.
Goes out of bounds.
See, we've become slightly nicer in some of our exceptions over the years.
This would definitely go out of bounds.
Right, that's exactly right. And then, of course, if this is Oracle, and when they do the connection, they go through and they set that catalog. That's what this else is all about. That way they've connected to the proper database specifically. Whereas if it's not Oracle, they don't need to set the catalog. Oracle is real wonky in that way. The method then connects to the actual database, which is what this is all about, and then it returns that connection back to the user, back to the caller. AA goes through and it lists all roots. That's things like C:/, D:// if you're on Linux, it's just /. Linux only has one root. That's one of the funny things to me about this is they then do this substring right here like this on it. But if it's a Linux system, it's only going to have a length of 1. So again, the application would actually crash at this point if you queried to see what the roots were and you were running Linux, because there aren't so many characters. They can't go through and do the substring from 0 to 2. It won't work. What they're trying to do though in this is get rid of the /. They only want the colon, C:, D:, all that good stuff. And we notice it takes all the roots, it iterates through all of the roots and puts them into that string buffer and then returns the string buffer. So the next big one is this BB. BB takes in a path S and a string buffer. What it then does is it lists all files within path S. So if we had, for example, /Etsy, it would list off Etsy host, it would list off Etsy shadow, Etsy password, all of that good stuff. But it also will go through and list off any directories inside of that particular structure. So it's going to show you the files and the immediate directories. That's all this is going to do. The next thing they do, which we see right here, is they grab that last modified date for each one of these files in this for loop, and they use this puppy here to format it into something pretty. The whole year, month, day, hour, minute, and that's, of course, the 24-hour clock, minute and second. And then the next thing they do is they check to see if they can read the file and if they can write the file. So that way they know in general what the permissions happen to be. And of course, this applies to directories as well. And then they grab the length. So the length of the file or the length of the directory, and they pump all of that into their string buffer. That's it. That's all this does. So this is literally just like running ls-lh or running dir. Same exact thing. EE recursively deletes all files and folders from a path down and then deletes that path. again, we'll take the simple example if we're talking /etc. It will delete etc host, etc password, etc shadow, all of the folders inside of etc. If you have like app armor or what have you, it will recurse through those folders, and it will recursively call to get those deleted. And then when it's all said and done, it would delete /etc. So that would be off the table as well. That's all EE does. So the next one that we have is FF. FF clears the response buffer. And the reason why it clears it is so that it can write. And the first thing it then does is it writes a hyphen and then greater than, and then it tacks on the XOR, the pipe. What they're doing there is, that's the Chinese character for knife. That would be the strokes you would do. You'd go here, and then you go 1 and 2. So I guess someone thought they were funny. So in the case of S here, see, they grab this file input stream. That's how they're reading the file. They then take and they pump the data from S out into their response. All this method does is send them the contents of a file, period. Nothing else. Just sends contents of whatever file, tacking on their funny little character because they thought they were funny. We do notice that they go through and close their streams. This actually isn't the best way or the right way. If there's any kind of problem that arises and they throw an exception, they will leak memory like mad, and they will have open streams. So it's not uncommon for malware to provide absolutely zero fault tolerance. Next we have GG. All GG does is write the string D to a new file S. Now you'll notice the way they do it is a little bit different. They've got this thing right here, and then they actually have to shift the characters over a little bit. This allows them to go through and use a mapping to write arbitrary data to the victim's computer, so to the server in this particular case, because of course this is being used on servers. So this is just a means for them to write files. HH does one of two things. It either copies the file S to the file to D, whatever D happens to be, or if S is a directory, it goes through and it copies all of the files within S and all of the folders within S to D. So it is an easy means for them to move data around, nothing more. II renames S to D, so it renames a file or folder. JJ creates the given directory S. So if you gave it /etc/fun, it would make the directory /fun. KK sets the file or directory's last modified date to whatever it was given. And again, obviously, if T were unparsable, meaning if it weren't in the format YYY-MM-DD, so on and so forth, it's actually going to throw an exception and this won't work. But its goal is to set that last modified date on that file. You see a lot of malware do this. It doesn't actually work well. They do this to trick someone who doesn't know better. But if you're doing digital forensics, you will immediately see that someone tampered with and changed the modified date. It's, as near as I can tell, it's only intended to skirt around checks that maybe a system administrator or a regular user would be doing. LL takes in the URL S and then writes whatever comes back from that URL to the file D. This is an easy means for them to dump data onto the computer. Say you want to put more malware on the computer. That would be how you could do this pretty easily. writes a stream to the stream buffer, it should be noted that they do /r/n, which is hard coded in here. That's a silly mistake, but it's very common. We know, of course, /r/n is Windows specific. It's not Linux specific, and it doesn't necessarily play well depending on what protocol you're using. So it's not well written code. If you were to take something like this and hand it to most any professor or most any developer who's been in the business for a little while, they'd scream, because you have these unclosed buffers, you have this unclosed stream reader, and then on top of that, you're hard coding in your line endings. And for no reason.
I don't believe they did, but in the beginning, did they even check the platform?
No, they don't. And if anyone's wondering, goes through and it grabs the name of all the databases in the database that we're connected to. So we see first it connects, and that's line 154, and then it runs a simple query to grab all the databases. It pumps those names into the buffer, and then it returns. Plain and simple. OO lists all the tables in the database. So you would give it, now when I say database, now I mean a database. Like the schema. Yeah, exactly. The schema, if you were talking something like Oracle, inside the schema you have the different databases. That's what we're really talking about here. So it will list them out, and it grabs all the tables within that. So and lists them, and then OO lists the tables. Plain and simple. PP connects to the database, and then it creates a statement. And you will see here, you see these two integers here. The first integer tells Java that it is a type scroll sensitive statement. That if a thread modifies the data in the database, that the result set that holds this data will then refresh and change to the latest information. The 1007 tells it that it's concurrent but read only. I don't know why they did it this way, since they're just quickly dumping all the data and then returning it. It seems a little silly to waste clock cycles. If, for example, I ran this select and it's a lengthy select because they're dumping all of the data inside of the table. Actually, excuse me. In this case, they're dumping the column name and column type. The data comes later. Right. So they're dumping the column name and the column type for the table. And that's each and every one of the columns. How often do they think that the columns, names, and types are getting changed? I don't get why they do that. It really made no sense to me, but I didn't write this code. If it were me, I would have not wasted the time with concurrency and with automated refreshes, because that can slow things down, especially since they're going to do that select all. So they get all the data out of the table just to grab the metadata, when all they needed was to grab one item from the table. So use limit 1, and then use that to grab the column names and types and things of that nature. So it's a very lengthy, expensive query. It would be even more obvious this way relative to if they did a limit of 1 or 50 or 100, something reasonable. Because if I have a massive table with hundreds of thousands of entries, it's now going to pull all of those before then getting the metadata, and then iterating to find the column names and column types. It's a lot of wasted clock cycles. It's an expensive, heavy call that may again tip someone off. This is not a stealthy tool. If you want to be found, use this. All right, so next we have QQ. All this does is execute the given statement. So QQ goes through and it connects. You'll notice Q is where the query is. If Q contains --F colon, then it expects it to also contain a -2 TO colon, and that dictates whether or not it's going to write to the buffer or to the file. So if you give it a to and from, which is what that F is for, then it will write to a file on the server. Whereas if you don't give it a to and from, it just connects, it runs the query, and then does its thing. And returns it to the string buffer, which then eventually gets returned to you. Do note, they do catch exception. Finally, they have a try catch.
What? They're actually doing error handling?
Well,
Wow.
but that was only because they were being lazy. And rather than figure out if the query was an update query, they just execute. And if the query fails, they catch exception. So rather than catching SQL exception or something like that, but if the query fails, then they try to run update. It's ridiculous. Absolutely ridiculous. So this gives them the ability to run arbitrary queries, database queries on your server, on that database server, whatever it's connected to. So now that we're done with that, those are all the functions that they have. Everything defined. They, first and foremost, used to have this parameter thing that they were apparently trying to maybe run checks against to see if they basically use that as like a password. So if you just have that parameter, then you get through. This is honestly the least secure piece of junk I've seen in a good long time. If you have the magic LC knife string parameter in your query, then what it does is it will take in an action parameter, a Z1 and a Z2. The action parameter tells it which method to call, and then Z1 and Z2 are just the parameters to that method. And we can see that in each one of these here, where it goes through and does its thing. We do notice they do close some of these buffers, but again, they actually still don't do it right. And if there is an exception, for example, in the method call, when this thing explodes, ultimately nothing will happen. Nothing positive, I should say, will happen. And you wind up getting these different streams left hung open. So it's very inefficient code. It suffers memory leaks. It suffers a lot of other problems. There are a lot of null pointers throughout here. They do that list, the list files call on something without verifying that it's a file, which will wind up exploding, or verifying that it exists, which would create a null pointer. If you list files on a directory, or if you list files on something that doesn't exist, you get a null pointer.
Since I want to say, and I don't know what you think, I want to say majority could be 80, maybe 90%. I want to say more than 90%, maybe 99% to 1% of the people that are actually writing malware suck at writing code. And you don't have to be a genius coder to understand how to or write malware. And you can suck at writing code and write a bad piece of malware that will destroy and do its job and still sucks. So yes, I will say 99% of the people that's writing malware or even exploits don't know how to write code sufficient. And as you see with some of the people saying, oh, you don't need to be a developer or a programmer to understand or write any malicious thing. So therefore you're going to get shit like this. And some of the times the malware screws up on its own and fails. How about some of those guys that actually write malware that the program did something it wasn't supposed to and turned it to something like a worm where it's an infinite loop, like,
Right.
you know, and then it does something crazy and destroys the fucking system or something. Just there's been weird cases like that, but that just shows you how bad that, you know, people are, or how much people suck at coding, and you don't have to be the greatest to write malware.
Well, and I think the other thing that's really important with all of this is someone might sit there and say, well, what does it matter if it's poorly written and it crashes frequently? And the answer to that is actually pretty simple. Every time it crashes, that crash gets written to logs. So if you're trying to tip off your victim write shitty malware, because they will figure it out with relative ease when they're sitting there going, what is this thing that's crashing? Well, why do I keep seeing exceptions all over the place? Why is my server constantly throwing 500s? And now they look into it, they start investigating, and bam, they find out that they've been infected. That's actually the most common way of figuring out that you have malware, is because your system starts crashing or you start getting errors all over the place.
Yeah, and then also you lose your connection.
That's right.
And it's how hard it is to get the connection in the first place.
That's right.
So you lose whatever, and especially if this was like a botnet,
Right.
a herd. I mean, now you kind of like lost that, and that is very important if you're trying to sell it, quote unquote, to
Right.
people, and you're losing that, you lose your money. So not saying that's a good thing to do. We're not saying you go do that, but if you're doing or writing malware and you're in the business for that, then if your code sucks, then you're going to lose clientele.
Right.
And you're going to lose, beacons and stuff like that. So you should learn how to write better code.
That's exactly right. And I want to reiterate for anyone who's listening, this was labeled an advanced persistent threat and advanced malware. Okay. This is how people who sat there and did the initial investigation were trying to label it. And after I was done laughing my head off, this is so basic and poorly written, it's not funny. This is not advanced. And it's just, honestly, it's incredibly buggy, incredibly poorly written code. And there's nothing positive I can say about this. But what I will say is, like I said, I've seen a lot of people claim that this is APT malware and that it's really advanced and so hard to understand. I mean, we just walked through that in almost no time. And that was the entire thing. And all it does is basic. It's reading files, writing files, pulling down from a given URL, and that's really it.
And to be honest, this is your basic bad. If you ask me, some of the basic functionalities you learned in college, but to be truly honest, they don't teach you the stuff that we're trying to say, that even from a secure coding standpoint or just writing good code, they don't teach you that in CS programs. Not that I learned in. This is kind of the crappiest code you would do, but it was kind of like the basics of understanding how to write code. But they did say that you should have try catches when you're in your code for error handling to catch different errors, but that doesn't mean everybody does. But what I'm saying in particular, that this just shows you that this was a really basic program, nothing advanced at all. And majority of the malware out there, it's not advanced.
Right.
It's not hard to do. I guarantee you, if you dissect it, if you created a honeypot, got some of the malware, capture some of them, you look at them, you would be amazed how easy it is for you to write your own if you were really interested. Not saying you should not write malware and you shouldn't do bad things, but it just shows you how simplistic it is to write one and how easy it is to actually do it and get paid.
Yeah, that's exactly right. Well, that's really it for today. I hope you all enjoyed it. I hope what you walked away with is the lesson that we've said before, that you don't need to be scared of these super elite Chinese hackers who are writing crazy malware that you'll never be able to detect. This is malware that they set on hundreds of thousands of servers, if not millions at this point. They still extensively use it, and they have versions of it for PHP, ASP.NET, etc. And it's ridiculously easy to detect because it's incredibly buggy, so it fails a lot. And it's also ridiculously easy to detect because there's nothing complicated about it, and it's very easy to scan for. So.
Yep. So with that being said, I'm Roniel.
I'm DaRon.
And if you haven't already, please like, comment, and subscribe to this channel for more content like this one. And if there's something that you want us to talk about or discuss, please feel free to email us or comment down below. And until the next time, start second.
Have fun.